Should we be afraid of the approaching comet 3I-ATLS? A silent traveler has entered our cosmic neighborhood. It appeared without warning, a faint speck of light moving against the backdrop of distant stars. This visitor is not from around here. It was born in a different star system, countless millennia ago, and has journeyed through the vast emptiness of interstellar space. Now it is hurtling through our solar system at an almost unimaginable speed, a fleeting guest on a journey that will ultimately carry it back into the void. It is the reality currently captivating the global astronomical community.
In the final days of June 2025, a network of robotic telescopes designed for a very specific purpose, to scan the skies for asteroids that might pose a threat to Earth, made an unexpected discovery. This system, known as the Asteroid Terrestrial Impact Last Alert System, or ATLAS, flagged a mysterious object moving rapidly towards the Sun. Within days, observatories around the world confirmed its nature. It was a comet, but its trajectory was unlike any object native to our solar system. It was moving too fast, its path too extreme to be gravitationally bound to our Sun. This confirmed its status as only the third interstellar object ever detected, and it was given the designation 3I/Atlas. The 3 signifies its place as the third such discovery. The I stands for interstellar, and Atlas honors the automated system that first brought it to our attention.
What immediately set this visitor apart was its sheer scale and velocity. Early estimates, based on the amount of sunlight it reflects, placed its nucleus at a diameter of roughly 10 to 12 kilometers. This would make it the largest interstellar object we have ever witnessed, dwarfing its predecessors, the enigmatic Oumuamua and the more conventional comet 2I Borisov. However, this measurement comes with a significant caveat. Scientists calculated its size by assuming its surface has a reflectivity similar to the comets born in our own solar system. But since 3I-ATLS is an alien entity, its surface composition, and therefore its ability to reflect light, could be completely different. It might be coated in exotic materials that make it appear larger or smaller than it truly is. As it draws closer, observations from more powerful telescopes will help refine this estimate, peeling back the layers of mystery surrounding its true dimensions.
Even more staggering than its potential size is its incredible speed. The comet is currently blazing through space at a velocity of approximately 209,000 kilometers per hour, which is about 58 kilometers every second. To put that into perspective, a journey from the Earth to the Moon, which takes conventional rockets about 3 days, would be completed by this object in just a couple of hours, and it is still accelerating. As it feels the increasing pull of the Sun's gravity, its speed will climb, peaking at around 68 to 70 kilometers per second when it makes its closest approach. This velocity is far beyond what is known as the Sun's escape velocity, the minimum speed needed to break free from its gravitational hold. This isn't just a flyby, it's a one-way trip. The comet is moving so fast that after it slingshots around our star, it will depart our solar system forever, never to return. This tremendous speed also presents a profound challenge. Upon its discovery, scientists at Michigan State University quickly ran calculations to see if it would be possible to send a robotic probe to intercept it. Such a mission would offer an unprecedented opportunity to study a piece of another star system up close, to analyze its chemical makeup, and to capture detailed images of its surface. The conclusion, however, was unambiguous. With our current level of technology, it's impossible. The object is moving too fast, and it was discovered too late. There simply isn't enough time to design, build, and launch a spacecraft capable of matching its trajectory and velocity for a rendezvous. We are left to be passive observers, studying this visitor from afar as it grants us a brief, tantalizing glimpse into its secrets. The story of this comet began long before our own solar system even existed. By tracing its path backward into the depths of space, astronomers have determined its likely place of origin,
the Milky Way's thick disk. Our galaxy is not a simple, flat spiral. It has multiple components, including a primary thin disk where our sun and most of the stars we see reside. Above and below this is a more diffuse, puffier region known as the thick disk. This area is populated predominantly by ancient stars, with average ages estimated around 10 billion years. These are stars that formed in a much earlier, more chaotic epoch of the galaxy's history. Coming from this ancient stellar neighborhood, 3I Atlas is believed to be a true relic. Its estimated age is a staggering 7 billion years or more, making it significantly older than our Sun and the entire solar system, which formed about 4.6 billion years ago. This celestial wanderer is a time capsule, carrying with it the primordial ingredients of a star system that was born and died long before our own.
Its journey through our solar system is as remarkable as its origin. By poring over archival images, scientists have been able to spot the comet in photos taken as far back as May of 2025, allowing them to precisely map its past and future movements. What makes its path particularly unusual is that, unlike the previous interstellar visitors, which arrived at steep, random angles, 3I ATLS is traveling in almost the same flat plane as the orbits of Earth and the other planets. It is currently inside the orbit of Jupiter and heading inwards. In October of 2025, it will make its closest pass by the Sun, at a distance of about 210 million kilometers. Its closest approach to Earth will be a comfortable 240 million kilometers, posing absolutely no threat to our planet. In fact, it will not even cross Earth's orbit. Its cosmic itinerary will, however, bring it much closer to some of our planetary neighbors. It will pass Mars at a distance of just 28 million kilometers, Venus at 97 million kilometers, and Jupiter at a relatively close 54 million kilometers.
The combination of its enormous size and its oddly convenient trajectory has inevitably led to speculation beyond the purely scientific. The most prominent voice in this discussion has been that of Harvard astrophysicist Avi Loeb, known for his bold theories regarding extraterrestrial technology. He has pointed out that the appearance of such a massive object traveling so precisely within the ecliptic plane is statistically improbable if it were a purely random natural event. He has suggested that this could be more than just a comet. It could be an artifact, an alien probe sent to survey our solar system. According to this line of thinking, the trajectory might be deliberately chosen to allow for close passes of multiple planets, perhaps to deploy smaller probes or gather data.
The broader scientific community, however, remains skeptical of such claims, emphasizing that while the object is unique and fascinating, there is currently no evidence to suggest it is anything other than a natural phenomenon. Extraordinary claims require extraordinary proof, and as of now, 3I/Atlas is behaving like a very large, very old, and very fast comet. Its passage is a golden opportunity for science, offering a chance to study pristine material from the dawn of another star system. As it gets warmer on its approach to the Sun, the ices on its surface will vaporize, creating a glowing atmosphere, or coma, around the nucleus. By analyzing the light from this coma using spectrographs, astronomers can determine its chemical composition with incredible precision. This will reveal what elements were present in the part of the galaxy where it formed billions of years ago, providing invaluable data for models of star and planet formation. For the coming months, telescopes both on the ground and in space will be fixed on this silent messenger from the distant past, patiently decoding the stories it has to tell before it vanishes back into the interstellar night.